Hello guys, welcome back to my YouTube channel. So now we are going to solve question number 2 of weekly contest 427. Maximum area rectangle with point constraints. Okay, so in this problem you are given an array points where points is having two values x and y which represents the coordinates of a point on an infinite plane. Your task is to find the maximum area of a rectangle that can be formed using four of these points as its corners, doesn't contain any other point inside or on its border. Okay, this is important line. Has its edges parallel to the axis. Okay, we have to return the maximum area that you can obtain or -1 if no such rectangle is possible. All right, so see this example number 1. These are different points we have, right? So what I'm going to do, I'm going to just add all these points in a set. Okay, because later on it will be easy for me to search. Okay, so I'm going to create a one hash set, and in that I'm just going to store these points, okay, in a string format. Okay, so I have this point, I have this point. All right, so this is the first thing that I'm going to do here. All right, okay, so now after that, once I stored all these points, so now after it I'm just going to find the points which are not horizontal to each other or vertical to each other. Okay, I'm going to find such points. So here if I see here 1 1 and 1 3, so 1 1, okay, simply means here, and 1 3 simply means here. So these 2 points are vertically, right, vertical to each other. So I'm not going to consider these. Okay, why I'm not going to consider this, I'm going to tell you guys later. Okay, so now after that, let's check this point 1 3 and 3 1. So 1 3 and 3 1. All right, so we can consider these points. Okay, these 2 points, okay, here and here. Okay, 1 3 and 3 1, I can consider these points. Okay, so here if you consider these 2 points, so what is the benefit that we are going to have? Okay, so these 2 points, okay, so 1 3, I'm saying that consider this point 1 3 and 3 1 because these points are not horizontal or vertical to each other. Okay, all right, so now here if, okay, 1 and 3, that is this, and 3 and 1, that is this point. Okay, so here you can do one thing here. Okay, so here I can form this. Okay, so we have 2 points. Okay, let's say this is my x1, this is nothing but my y1, and this is nothing but my x2, and this is nothing but my y2. Okay, so from these 2 points I can try to search for these points. One is uh, 1 and 1, okay, x1 and y2 and x2, this, and y1, x2 and y1. Okay, what is x1 and y2? X1 and y2 is 1 1, okay, and x2 y1 is 3 3. Okay, so here what I did, I first check if these points are not horizontal or vertical to each other, and if these are not, then I'm going to check these points x1 and y2 and x2 and y1. Why? Question is why. So see here, for a rectangle, okay, for a rectangle, if this coordinate, okay, so for in your case this coordinate, so here x1 and y1 and this coordinate, okay, these are the 2 points that you have, x2 and y2. Okay, so what you are searching, you are searching for the rectangle, right? We have to find the maximum area for rectangle. So definitely what we are thinking about, we are thinking about this point and this point. So how I'm going to achieve this point? So I'm going to achieve this point. Okay, I'm going to achieve this point by considering this as my row. Okay, this as my row, okay, which is nothing but my x1, and my column is going to be the y2. Okay, so x1 and y2 as my column. Okay, row is going to be x1, okay, and my column is going to be y2. Okay, and if I want to consider this point, okay, so for a rectangle form we need these sides now, right? And this side is nothing but Okay, so this side is nothing but your x2, okay, and your column is y1. All right, so these are two other points we are searching. Okay, we know that if it is a rectangle, if we have these points, then for rectangle to form we need this point and this point. Okay, so that simply means 1 1 and 3 3. Okay, so now here uh, we are going to search for this point 1 1. So 1 1 is there, so that is why I am storing this in hash set. Okay, 1 1 is there and 3 3 is also there. Okay, so this is clear, right? So we have this point, so here let me write it like this. This is nothing but 1 and 3, and this is nothing but 3 and 1. Okay, so here this is x1 y1, this is x2 y2. Okay, so now what is this point? This point is nothing but 1 1. Okay, so 1 and 1. Okay, and how we are forming this 1 1? Okay, so this is nothing but my x1. Okay, so here I am writing x1, and this one, see this y1. Okay, x1 y1. So now you guys must be there, x1 y1, and this point, okay, this 3. Okay, this 3, so this 3 is coming from this x2. Okay, x2, and this y. Okay, y1, x2 y1. Okay, so now I hope that you guys clear. So we know these 2 points diagonally. Okay, and then we look for these 2 points. So yes, these 2 points exists, so that simply means that this is one rectangle. Okay, and if this is a rectangle, then what I'm going to do, I'm just going to calculate the length. What is the length of this edge? So how we are going to calculate the length? X2 minus x1. So it is going to give me what? This x2 and x2 same. Okay, so we are going to find the length. Okay, so here what is this point? 3 1, and this point is nothing but 3 3. Okay, so here in this side we are just going to find the y2 y1. Okay, 3 minus 1 is 2. Okay, and this side length is, this point is 3 1, and this point is 1 1. So 3 minus 1 x. Okay, in x axis what is size? So 2. So 2 into 2 is going to be 4. We can make a rectangle with these 4 points as corner, and there is no other point that lies inside or on the border, hence the maximum area would be 4. Okay, so this is how we need to check. Okay, so from here I think you 2 points are clear for you guys. Okay, so first we are going to find the points which are not horizontally or vertically, and once we find those points, then after that I am going to find the x2 y1 or x1 y2 for those points. Okay, or x2 y2 and x1 y1 for those points. Okay, the other diagonal points. Okay, and if these points exist, then they can form rectangle, and if they can form rectangle, then I'm going to search if there is any point inside this rectangle or on the walls of this rectangle. Then we have to return false, then that is not a rectangle. Okay, so see this example number 2 here. So we can form this rectangle, but there is one point inside it, so output is going to be -1. Okay, so now let's move to the solution part. Okay, but I hope that you guys are clear with the logic. So here we are going to create one hash set of string. Okay, and I add all the points here. Initially I took the max area as -1, then I'm going to iterate over all the pairs of points. Okay, so all the pair of points, so first these two, then these two, then these two, like that. Okay, so I is equal to 0, I is less than points dot length, and j is equal to I plus 1, and j is less than points dot length. So here I have calculated the x1 y1 x2 and y2. Okay, so this is what I'm doing here, x1 y1 x2 and y2. Okay, this is what I have calculated. Then this is what I have calculated here. Then I am going to check if points must not form a vertical or horizontal line. Okay, so I have explained this as well. So if x1 is not equal to x2 and y1 is not equal to y2, then we have to check if other 2 points exists. Okay, if these points are there, then we have to search for this point and this point. If we have this point, we have to search for this and this point. Okay, so here p3 x1 y2, and p4 is x2 y1. Okay, something like this we have to search, and then we have to check if our set this contains those points. Okay, if those contain those points, then we can find the area as x2 minus x1 and y2 minus 1 y1. This I have explained until here, and then I told you that we have to check if a rectangle contains extra point inside or on its border. So for that I am going to call this method. Okay, if it returns true, then I'm just going to calculate the max area as we have to return the max area. So we are going to calculate the max area and we have to return max area. Now this is clear, right? So now here how we are going to check if a rectangle is valid. So here I consider all the points x1, y1, x2, y2, and here I have passed my set. Okay, then I have calculated the mean. Okay, what is the minimum value of x, what is the max value of x, okay, what is the minimum value of y, what is the max value of y. Okay, so I consider all these. So these are the points in a rectangle. So x and y mostly remain same, right? Okay, so here we have considered the min and max. Okay, then I'm just going to iterate over all the points. Okay, so x is max min less than x max. Okay, so same for y, and we are going to check all the points. Okay, so points should exist only if it's corner. So if it's corner, then we are good, then don't do anything. Okay, so here if point set dot contains points, okay, then just check if this is not a corner. Okay, if that point is not a corner, we are going to check all the points. Okay, all these points. If that point, okay, if the point existed is not a corner. Okay, if it is not a corner, then extra point inside or on the border, that simply means, so we are returning false. If it is returning false, then we are not going to calculate the max area. Okay, but otherwise we are going to return true. So this solution is accepted, right? So I hope that you guys are clear with question number 2 of weekly contest, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. And don't forget to like this video, share this video with your friends, and please subscribe to my YouTube channel so that you get daily updates on the LeetCode daily problems and the weekly contest. Thank you. Bye bye.